Hello and welcome back. This is a Bedini Schoolgirl circuit. I've got it running on 90 milliamps and 12 volts, 10 volts, sorry. And there's a schematic of it, the Darkman circuit. The difference here is that I've got a smiley face, a neon bulb to take up the back EMF instead of charging a battery, and there you go. So that's working. The other thing I've got is I've got a coil. So this is a tri-filer, and there's also an air core circuit. So no steel in there or anything. And if I dead short the third coil, you will see that it actually kills the motor. Okay, there, nothing gone. So it's killed the motor. So I'll let it get back up there. The other thing I've done with this particular setup is I've actually put a capacitor across these two outlets here, rather than a hard junction. You see on the Darkman, you've got a solid junction there. However, I've chosen to put a capacitor, and that helps just with the tuning of it. So there you go, that's something I've done. But anyway, some things I want to show you building onto this is, okay, let's get a good one. This is what's called a pickup. So what you've got a large LED, and you've got two germanium diodes heading from the negative to the positive, and that picks up ambient electromagnetic radiation from the pulsation of the system. And there you go, you can see it running. There you go, it's pretty good. And I can also put on the third wire that's not attached to anything. There you go. But there's some things about this setup that I'd like to show you. Hang on, there we go. One is, what I'll do is, I'll put first of all, I'll put it across the third wire and show you the result. Okay, here we go, I'll try this. And we'll see a difference. Hang on. So now we've got it set up, you can see the positive and the negative, going to the positive and negative of my third coil. And so let's hook it up and you'll be able to hear the difference. Okay, so that's on full brightness. You can hear the motor slowing down. That's put a drag on the system, and also you can see the voltage has gone up. Now what we're going to do is we're going to add two of these together and see what that does. Right, so I've got two together. I'll touch them together in a second, but you can see how we're getting, these are so sensitive, they're not joined, and also both of them are now putting out a little bit of power, just a one wire system. But I'll touch them together and we'll be able to see the difference. There we go, full brightness, speeding up, and only a marginal increase in our voltage. You can hear it speeding up. That's pretty good. Okay, so on with the next trick. Instead of running these in series, I'm going to run them in bucking style. That is to say, turn this one around so that the negatives face each other, and we'll see how that goes. I've done the switcheroo and touch them together. They're on full brightness. A change in the motor, but it's not speeding up. And also our voltage is a little bit higher, but not too much higher. It's off, so 1 volt higher. So that's pretty good. Now I'll switch that one back and turn that one around. Hang on. Touch them on. So same effect. Okay, and same result. Now what we're going to do is, I'll show you if I can find it. This is what's called a neon or a smiley face, and I have done the same trick with the germanium diodes, and the difference this makes to the motor is significant, as you'll see. Now let's get in the right position. Now this is a 100-volt neon, so oops, hang on. Oops. And you can see that's absolutely killed the motor. Righto. Now what I'm going to do is I'm going to change the polarity, and you watch the difference. As you can hear, that's recovering. All right, so ready to put. So I've turned this around, turn the polarity the other way, and you watch this. That's supposed to glow. Anyway, you can hear it speeding up. It's dead shorted the circuit, and it's going faster and faster. But that's not all. Now we're going to run one of these in conjunction with that. Ready to go, so I'll just touch. They're both in the same direction, so in series. You can see it's got the same effect, making it speed up and using extra voltage to do it. Now we're going to turn one of these around and make it face each other, as in bucking style. Okay, do that. Okay, so we've got full brightness. It's also speeding it up, and we don't have as much voltage consumption. Now what I'll do is I'll turn the neon around. Okay, so this is where you have to pay attention. I've changed it around so that our neon, or our smiley face, positive, faces the positive of our LED. So what we're going to do is we're going to touch them together. So see, we're using 5.85 down to, so you watch the difference when I touch them together. Now remember, this is 100 volts. Current's small, but 100 volts, all right? Here we go. So we've got 100 volts coming out there. Hasn't changed the wheel, and we're using 5.3 volts, so no difference. That's pretty amazing. But wait, there's more. Okay, so 5.85, there we go. Got that one and that one as before, except I've now got a joiner there. But now I've got a third one of these. Okay, it's polarity, and it doesn't really matter which way it goes around. You can see, don't know if you can see, positives on this side, positives opposite on this one. All right, let's connect it up. They all go, not hugely brightly, but they're all running. Absolutely no difference, and using less voltage at the same current. So tell me how that's possible. Anyway, I'll change these over and we'll hopefully get them full brightness. Okay, so I've rigged it up so they're all going. Got consistent motion on our wheel, and 5.89, so very little increase in voltage used. But now we're going to step it up a bit. All right, watch this. So what I'm going to do is, I've got to figure out how to do this. I'm going to disconnect one of them. Hang on, I'll figure it out and come back. Okay, so I've disconnected my positive, as you can see. Also, I've turned my smiley face around, and this one's still the same, but this time we've got a earth wire to true earth. If you can see that, it's got it down into true earth there. All right, so now watch this. There you go, 100 volts, and we've got a lighted thing. Really no increase in power. So now it's going to earth. So I'll just flip that one around. Flipping that diode around, you can see that it actually makes no difference at all to anything. Okay, now I'll try this one. Okay, this is going to be the last show and tell for the day. You can experiment in the future yourself. So what I've done is I've disconnected, you can see that's a positive rail of that third coil. I've disconnected that from our circuit, yet it's still going. 2 LEDs and a neon, quite bright, 100 volts there. Nice and bright, nice and bright. And that's running on that particular rail, or that particular strand, if you like. And the earth is once again connected to our true earth, which is our board there. So that's pretty interesting. Oh, and also hasn't changed the RPMs or in fact our any consumption. So what I'm going to do is I'll just fiddle a bit with the dial. You can see that one's kicked in, all of them are kicked in, nice and bright, nice and bright. And of course we are using a bit more of the voltage. So turn that down a bit. We can also play with the current a bit, crank it up. At the same time, our lights also get a lot brighter. So now we've got 0.8, 140 milliamps this time. With that neon protecting that TIP 3055. It's cranking that. Don't know how fast it's going. And yeah, got all our diodes, LEDs connected to True Earth, as well as that neon, little neon. Yeah, and they're all, yeah, just muck around and yeah, you'll find that. All right, I think that's about it. Tell you what I'll do, I'll just turn that off. And as you can see, they're now a little bit low. If I turn it up, sure enough, it gets brighter. And our power supply is now a little bit unstable, but there you go. That's something to have a look at. Extra winding there that you tap into, and connect these in a bucking configuration also helps. Yeah, that'll be enough for today. Thanks for watching. Catch you later. You twist my arm. One more demonstration. I think it's a perler. You're gonna love this. Okay, we got it cranked up. It's hard to tell what sort of voltage, around 9 volts I'd suggest, somewhere around there. Anyway, what I've got here is one of my LEDs, and that is running from one side of our coil through the LED to earth, and I've got the other side of the coil still attached to our smiley face or our neon. And remember, this is one wire, but look at this, that's running. That's incredible, isn't it? Okay, so what I'm going to do now is I'm going to make it even more incredible, and just so you can see all in the picture. All right, what I'm going to do is, if the thing will focus, is I'm going to touch this or short this one out. Hang on. Yeah. Okay, so that's going, but that one's still the same. All right, but wait, hang on, I'll get that going. If I touch that, look at that, they're both going. And that, and no, well, you can't really tell, but there's no difference. You can hear the rotor. There's no difference with the rotor. So once again, I'll just touch the end. That's amazing. So that's basically shorting out both ends. So this red end's going to earth through that LED. And I wonder how many LEDs you can actually put through there. And that's going through to true earth. And then this side, I've got earthed. And well, if I put it to true earth, I would have the same result there. That's pretty amazing. That's incredible. I'll slow it down a bit. So I've just slowed it down back down to 90 milliamps. So, and I'll just adjust this. Bring that one on. As you can see, we've still got the same effect going to earth. Hang on. Yep, going to earth. That one wire is not touching anything. That's still going. Our smiley face isn't, so I'm going to touch that. Bang, comes back on. That comes back on, bright enough. That's still on. Okay, now come on. Okay. So everything's on. 6.37, all right, 6.38. Now I'm going to let go. 6.4, 6.3. So it's using less voltage when I hold it back to earth. That's pretty amazing. The question is, if we earth that one to true earth, how bright will they become? Like that one? That's pretty bright. I reckon that's probably half lit, half fullness. Okay, so what I'm going to do is, you can still see that one going, if I touch it, sort of goes a bit brighter. That one's still running. What I've done is I'm going to use the earth, the real earth, through our multimeter, and this neon will go out, but watch this. No change. Oh, I should have done that first, hang on. All right, 6.5, drops the voltage down, amps haven't changed at all. Our neon there's gone down, so back EMF is gone down. All right, but check this out. Man, look at that, full brightness, and our neon's gone off. So basically that coil's been earthed on both sides, and we're running neons and LEDs on both sides of the earthed coil of the third coil system. That is next level, and it's consuming less power. That's next level, folks. That's pretty interesting. I highly recommend you have a crack at that. There we go. No change in the rotor, disconnected. No change. Connect the bat up. No change. Still. Thanks for watching. Catch you around.